Alright, so let's review some basic integration, okay? So when we first started learning integration, remember your function has to fit this table, okay? Meaning the function has to look something like one of these functions that we have right here, okay? So remember, this is not in your formula book, so you need to kind of memorize this integration table and make sure you know how to integrate when the function looks something like one of these right here, okay? And then we also have another table that's really important. All right, so this table right here, remember this is when you're integrating something of some function in the form ax plus b, okay? Now the only thing different between basically these functions and the one prior, right, is that these functions, there's a number that's going to be in front of the x that's other than 1, right? So we have some sort of constant in front of the x that's other than 1, okay? So whenever you kind of see, so right here we have, you notice ax, right? Meaning there's some constant other than 1 in front of the x. So whenever you see that in the function, basically you just need to remember that when you first start integrating, you need to have 1 divided by that number that's in front of the x, right? That was the only thing that was different when it comes to integrating between the previous table, all right, and then this table right here, okay? So take a moment and review this table where the function, right, is in the form ax plus b, okay? So now let's do some examples so I can show you guys. All right, so the first example, let's see. So let's say we need to integrate just a constant. You need to integrate a constant, let's say for example 3, right, dx. So if you integrate this, right, if it's a constant, basically all you need to do is just attach an x to it. So you would get 3x, right? Now, whenever you're integrating and there are no numbers here, right? If there are no numbers here and here, that means it's an indefinite integral. So whenever there are no numbers here and here, right, that means that it's an indefinite integral. So that's when you have to have the plus c, okay? Let's try another one. So let's say we have e to the x, right, dx. Well, if you recall, the derivative of e to the x is e to the x, right? So if you integrate e to the x, you're going to also get e to the x, right? And then we need the plus c, okay? Or let's say we need to integrate 1 over 3x plus 5, okay? So this is one of those examples that are in the form ax plus b. So you have to recognize right here, like, hey, I've got this number right here that's in front of this x, right? So when you're integrating this, so recall, what you're going to do is, well, I'm going to first start with this number right here. So I'm going to have 1 over 3, right? And then, if you remember, you have 1 over, all right, 3x plus 5. This is going to actually give you a natural log, right, of 3x plus 5. And then we need the plus c, okay? All right, let's do another example. Let's say we need to integrate sine x. So if you need to integrate sine x, right, so we know this is going to give us negative cosine x, and then we need to have the plus c. Or if you're going to integrate, let's say cosine x, we know that this is going to give us sine x plus c. All right, so these are pretty much straight from the integration table. Now let's say you have a number in front of the x, for example, sine 5x. So if you're going to integrate sine 5x, right, then you have to notice there's a number in front of the x, some constant other than 1 in front of the x. So we would have 1 over 5, right, and then you would have negative cosine 5x plus c. So if you simplify this more, you would end up with negative 1/5 cosine 5x plus c. Okay? Let's do one more. So let's say we have 3 over 4x plus 1. So first of all, if you recall, we have a rule where it says if we have a constant, we can pull this guy out. So first of all, we can think of this problem as 3 integrating 1 over 4x plus 1. So first you want to always pull out that constant, okay? And then now you have to recognize, okay, I've got this 4 in front of this x, so if I integrate this, so I have this 3 right here, if I integrate this, I'm going to have 1 over 4, and then this is going to give me natural log, absolute value, 4x plus 1, right? And then we have the plus c, right? Then the plus c. So basically we have 3 over 4, natural log, absolute value, 4x plus 1, and then don't forget the plus c. All right, let's integrate, let's say 4x plus 3 to the 8th power, okay? So if you're going to integrate this, so first of all, you have to recognize that, okay, I've got a number, this value in front of this x, right? So if I integrate this, I'm going to get 1 over 4. I start with 1 over 4. And then think of this as like a power rule. So then we would have 4x plus 3. We would add 1 to this, which is 9. And then we would divide by, right, what the new exponent is, which is 9. So we fully simplify this. Basically, we're going to get 4x plus 3 to the 9th power over 4 times 9, which is 36. And then we have plus c. Okay? All right, let's try maybe 2 more examples. Let's say we need to integrate, for example, sine 5x minus 4. Okay? So once again, we recognize, hey, we've got this constant in front of this x. So when I integrate this, first I'm going to start off with 1 over 5. And then if I integrate sine, I know that's going to give me negative cosine. Right? And then we just copy whatever this angle is, 5x minus 4. Right? And then we're going to have the plus c. So if we simplify this, we're going to get negative 1/5 cosine 5x minus 4, and then we have plus c. Okay? Let's take a look at, alright, let's take a look at another example. Let's say we have 4 over 2x plus 3, right? So first of all, we have this constant, so we know we can pull this guy out to the front. So we would get 4, now we're integrating 1 over 2x plus 3, right? So we have the 4 right here, times, now we integrate this, so I recognize there's 2 in front of this x, so then that's going to give me 1/2, right? And then this will give me a natural log, absolute value, 2x plus 3, right? And then we would have the plus c. So let's simplify this real quick. The 2 and the 4 simplify, so we would get 2 natural log, absolute value, 2x plus 3 plus c. Okay?